Okay, hi, my name's Vivian Zacher. I'm a rising senior in biomedical engineering at Florida State University. And my project is 3D printing and physical characterization of a bioabsorbable mesh. So the goal of this project was to evaluate different printing parameters of polymers such as polylactic acid and polycaprolactone. So those are known as PLA and PCL. And then after 3D printing these, we were able to evaluate the mechanical properties using tensile testing. So bioabsorbable implants are able to break down in the body over time. So they're being used in regenerative medicine. So figure 1 over here shows PLA, its chemical structure, which is a biodegradable material that I used. And biodegradable materials have many advantages compared to non-degradable ones. They can eliminate the need to be removed, and then they can promote wound healing and lower patient risk. So to do this, we use fused deposition modeling, and we extruded PLA filament into a mesh. So figure 3 shows the CAD file that I used of the mesh. And then we did mechanical testing at 205, 207, and 210 degrees Celsius. And then at these temperatures, we printed 1, 2, and 3 layers, which each layer being 0.25 millimeters. And then we also printed PCL using photon polymerization using the UpNano printer. And then for the results, so we confirmed the printability over here in figure 5. So the left is the PLA and the right is the PCL material. And then in figure 6, you can see the stress versus strain curves of the mesh, the PLA mesh at each temperature and different layer heights. So then we use the elastic region here to determine the Young's modulus with the slope. And then the ultimate tensile strength was the highest point on the graph. So we found here the largest Young's modulus was PLA printed at 205 degrees Celsius with 1 layer. And this was 2,538.3 megapascals. And then the largest ultimate tensile strength was PLA printed at 207 degrees Celsius with 2 layers. And this was 29.5 megapascals. So we found the ultimate tensile strength to be greatest in samples printed in 2 layers. And this could have been done because of samples printed in 3 layers having an increase in porosity, which can be looked at in the future using scanning electron microscope. And then we need to do additional testing for the PCL mesh, but sorry, I don't know why this video isn't playing, but I could show it afterwards. This is a video of the flexibility of PLA, but it won't let me escape out of here. Sorry. So that shows the flexibility of the PLA mesh. And then we found the greatest TS as a PLA printed at 207 degrees Celsius with 2 layers, and the greatest Young's modulus to be PLA printed at 205 degrees Celsius with 1 layer. And we want to do additional research for the degradation profiles under physiological and loading conditions. And then also I plan to continue this work during the semester and give an updated presentation at the Biomedical Engineering Society Conference in Baltimore, Maryland.